All right. All right, the other day we talked about that if we had 7 to the 6th power times 7 to the 9th power, that would be 7 to the 6 plus 9 power, okay, which would be 7 to the 15th. Okay, well, multiplication, so when you're multiplying two bases that are the same together, then you add the exponents. Well, division is the inverse of multiplication. Subtraction is the inverse of addition. So, if you're going to divide bases that have the same bases, then you're simply subtracting their exponents. Okay? It's always the top exponent minus the bottom exponent. So for this one here, this would be 7 to the 6 minus 9 power, which is 7 to the 3rd. Now, for some reason on these, they do just the opposite of the multiplication ones. They want you to simplify all these. Okay? Because a lot of them, well, probably 70-80% of them are going to end up as fractions. And so they want you to simplify the expression, which means simplify the fraction. Okay? Yeah. Yeah, -3. So that means that's 1 over 7 to the 3rd, which is 1 over 343. Okay, because it's 7 times 7 times 7, not 7 times 3. Okay, so if this was reversed, if it was 7 to the 9th over 7 to the 6th, then it would be 7 to the 9 minus 6 power, and then it would be 7 to the 3rd power, and it would be 343. Obviously, the reciprocal, because we reciprocaled the fraction. Okay, so fairly simplistic, okay, as far as that goes. Now, the rule for exponents outside of the parentheses, for example, this, is the same. Okay, you distribute the 6 times both of those. And so you have x to the 3rd power times 6 over y to the 5th power times 6. Which means I have x to the 18th power over y to the 30th power. All right, now, if I have this, a little bit different here, not a whole lot, but a little bit. I have this right here, x to the 4th over x to the 5th. So that means I have x to the 4 minus 5 power. That means I have x to the negative 1 power. Can't have a negative in my exponent, so that's 1 over x. All right, I want you to try this one on your own. We have a to the 9th over a to the 5th, the whole thing raised to the negative 1st power. This is a little bit more difficult. Did you get a fraction, Matthew? Larry? You got me an answer, Larry? You guess? Yes, 1 over 8 to the 4th. Now, two different ways that you can do this problem. First way is to distribute the -1 to both things. Okay? If you do that, that means you have a to the -9th over a to the -5th. If you subtract those, you would have this. Okay? And that would be plus plus, which would give me a to the -4th power, which is 1 over a to the 4th. The other way that you can do it you can go ahead and do this, which is a to the 4th raised to the -1st, then distribute, and that would be a to the -4th, which is 1 over a to the 4th. Either one of those ways is acceptable. All right, now, try this one. R to the 3rd raised to the 4th power over r to the 3rd raised to the 8th power. Blake, what'd you get?
R to the 12th over R to the 4th.
We got to reduce it. Yes, that is correct, but you got to simplify it. You got to simplify it. Nick, what'd you get? Hurry up. Zach? Yes, 1 over r to the 12th. What Lake said was correct. He distributed the 4 to the 3, which gives you r to the 12th. Then the 8 to the 3, which gives you r to the 24th. But now I got to go r to the 12 minus 24 power, which is r to the -12, which means I have 1 over r to the 12th. All right, let's look at this one. A few more little...
Should we do on the board? 41.
No. Now it becomes a little bit complicated because you have to distribute the 3 to every single thing in the parentheses. Okay? So that's -6 to the 3rd, x to the 6th, y to the 3rd on top, then 2 to the 3rd, x to the 3rd, y to the 9th on bottom. Now's the time you need to see this as really three separate entities. Now 6 to the third would be what? 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 Negative 216 from the re-energized Larry Singleton. And then 8 on bottom times, if you'll look at these folks right here, 6 and 3. 6 minus 3 is 3. The large one's on top, so it's x to the third over 1 times 1 over y to the 6th. All I did there is just subtract those. 3 minus 9, the larger one, wherever it is, top or bottom, it stays on the bottom or top, whichever it is. So now I have 8 into 216. What? No. 8 goes into 216. Negative 27 over 1 times x to the third over 1 times 1 over y to the 6th. And so that gives me negative 27x to the third over y to the 6th. Because 1 times 1 is 1, 1 times y to the 6th is y to the 6th. Hush, y'all. You have to treat them as 3 individual fractions. Now, the confusing part. Let me see here. 42. 16x to the third y over negative 4xy to the third times 2x negative 2xy over, wow, is that another negative sign? Yeah. Negative x to the negative first. All right. Now, once again, okay, these are just regular fractions. They've just made it a little bit more complicated. Okay. First thing I can do is this. Does that cancel? Okay. 4 goes into 16 4 times, so that's 4 over 1. Yeah, I'm getting there. Negative sign out in front times x to the second on top, 1 on bottom, times 1 on top, y to the second. Okay, so that one reduced is negative 4x squared over y squared. Huh? Okay, hang on. Nobody talk, nobody say anything. Right here, Zach, that's y to the first over y to the third. So in my mind, I'm just doing this. 1 minus 3, which is y to the negative second power, which means that's 1 over y to the second. And the other way to look at it is this way. The easiest way to look at these when you're doing division is if you can visualize this, here's what you have right here. You have 1. That's what you have, okay? Those two cancel out, leaving me with 1 on top, 2 y's on bottom. I mean, realistically, that's the easiest way when you get to these complicated ones like that, is just look at it. So just subtract their exponents. Is the large one on bottom? If it is, put the answer on bottom. If the large one's on top, put the answer on top. And that's all there is to it. Now, over here, this cancels each other out, makes it a positive. So I have times 2 over 1 times x to the first over x to the negative first times y over 1. Well, this right here is x to the 1 minus negative 1 power, which is what? Nope. Plus plus would be x to the second. So it is 2 over 1 times x to the second over 1 times y over 1. Okay, so I'm going to bring that down. 2x squared y over 1. And we're not done yet. Because now we're going to cross cancel. And realistically, all you're doing is this. Let's look at this right here. If I combine those two fractions, it gives me this. Negative 8 x to the fourth y over y squared. That's all it does. Okay? Well, instead of cross-canceling, I can say here, those two are the same. And so that gives me negative 8x to the fourth. The 1y up here cancels out, and it knocks that down to a 1. So that's your answer. And that was a simple one.
No, we should do like 47. Come back into work.
It doesn't cancel out y2. It cancels it to a y to the first. Same thing we just talked about. Because you have y here, and you have y to the second there. That's y over y times y. Those two cancel, leaving me with 1y. The other way that they show you, obviously in the book, is when you have this here, there's a 1 right there. So that's y, 1 minus 2, which is y to the negative first, which is 1 over y. All right. Let's see here. Let's look at 44. 44 says 36 a to the 8 b to the second over ab times 6 over ab squared, the whole thing raised to the negative first. So here's what I'm going to do. This right here, since it's to the negative first power, then I can do this. 36 a to the 8 b to the second over ab times ab to the second over 6. Because of that sign right there, I can do the reciprocal. And since it's raised to the first power, it doesn't change anything. Now, I can cross cancel. A and A cancel. Okay, now, this gets back to where we got to look at this. A b to the first and a b to the second. Okay, that's going to knock this b out and knock that b down to the first. Yeah, I'm fixing to. Just give me a second. 6 goes into 6 once. 6 goes into 36 6 times. So on bottom, the only thing I'm left with is 1. So that leaves me a 6, a to the 8th, b to the 3rd. And where I got b to the 3rd were those two right there. B to the 2nd times b to the 1st.
So you don't add the extra a on a.
There is no extra a. All the a's are gone, except for the a to the 8th. This one right here is gone. This one's gone, so there's none left. Now, the other way that you can do that problem once you get to this point is you can multiply it straight out. It just ends up taking a little longer. I mean, if I multiply it straight across, that's 36, a to the 9th, b to the 4th, over ab, 6ab. Okay? Well, those right there can reduce to 6 over 1. A to the 9th, a to the 1st, a to the 8th. And here, b to the 4th, b to the 1st, b to the 3rd. All over 1. And so either way, you're going to get the same answer. The problem with doing it that way is you're going to get some fractions that are eventually they're going to get even more complicated. And so it's going to be hard to multiply them out. I mean, here in about a month, we're going to have fractions that are 4 fractions long, and you're having to, it takes, 10 lines to do it. All right, let's look at 48. Last one of the day. 2xy to the negative 2nd, y to the 4th. They're just really making this a lot more complicated than it needs to be. Then I have 3x to the negative 1st, y raised to the negative 2nd power times 4xy over 2x to the negative 1st, y to the negative 3rd, whole thing raised to the 2nd power. Now, when it's more than to the negative 1st power, I don't suggest flipping it. The other thing you need to look at is this. Do these right here cancel each other out? Okay? If I flip it, I can still cancel out. Okay? But the bottom line is I've got to distribute both of those 2's to the parentheses. So I have to distribute negative 2 to everything inside there. And I have to distribute this 2 to everything inside there. Huh? Y to the what 2? Yeah, you could do that. Huh? You're going to end up with the same thing either way, but yes, you could. You would add them. You would add them. Be negative 2 plus positive 4. All right. You were here yesterday. You just weren't Tuesday. All right. Now, so that gives me 2 to the negative 2 power. X to the negative 2 power. Y to the 4 power. Y to the negative 8 power. Over 3 to the negative 2 power. X to the 2 power, or negative 2, or excuse me, 2 power. Y to the negative 2nd power. Times 4 to the 2nd power. X to the 2nd power. Y to the 2nd power. Over 2 to the 2nd power. X to the negative 2 power. Y to the negative 3rd power. Or negative 6 power, excuse me. I understand that you have a mark for today. Yeah. What I do, yeah. Now, here's what you have. You have a lot of stuff. Okay? All right. First of all, I can do this. This and that cancel. Okay? This and that cancel. All right, now, this right here cancels, making this a 2. Do what, Zach? Yeah, it's negative 2, yeah. Okay, now, this and this cancel. Right. Think of it. See, if we have y to the negative 2nd over y to the negative 2nd, that's y negative 2 minus negative 2, which means those become plus. That's why they cancel. Okay? Now, so what we have left, let's put what we have left. We have 2 to the negative 2nd over 3 to the negative 2nd times y to the 4th over 1 times 4 to the 2nd over 2 to the 2nd times y to the 2nd over 1. Now, these two right here, I just flip them. Because of my negative here and my negative here, they just flip, and that gives me 9 over 4 times y to the 6th over 1, there and there, times 16 over 4, which is 9 over 4 times y to the 6th times 4 over 1, which is cross cancel. So 9y to the 6th. Huh? Now, up here at this step, okay, up there at that step, you could take and join those two, but they end up, there's a lot of different ways you could do it. Okay, the bottom line is, find the way that helps you remember the rules the best and do it that way. Okay? Your homework. All right. 20 through 30 even. And this is 8.3. And 35 through 48 all. Nope. Still have plenty.